Hello students, we're back for more Grignard Practice. Here's Grignard Practice number 2. In this particular case, I have 2 exercises. They're kind of similar to each other, right? They both involve this 5-membered ring. In this particular case, what I want you to do is, I've given you the reactants. I want you to think about what the products are. In 2A, we have something that has 3 different ketones present, and we're going to add 3 equivalents or 3 moles of this bromoethane. Let's treat this bromoethane with magnesium in the presence of ether to make this our Grignard reagent. What happens when this Grignard reagent reacts with this, right? You'll want to put your answer over here. And for 2B, we have basically the reverse, right? So here I have a 5-membered ring where I have bromine, bromine, bromine. Let's suppose we treat this compound with magnesium in the presence of ether, and we make this our Grignard reagent. Then to that, we're going to add 3 moles or 3 equivalents of this compound right here. I want you to draw what product you think you'll have for 2B over here. Please take a minute, pause the video, try out both of these, write those 2 different products and compare them, and after you've had a chance to look at that, we'll come back and talk about it. Okay. I assume at this point you've hit pause, you've tried this out, and you feel like you're feeling pretty good about it, I can tell. Let's have a look at these. For the first one, right, here's our electrophile, the place that's partially positive. Here's our nucleophile, we're making a nucleophilic carbon here. Those are going to react together. Remember, the new bond is being formed between this carbon and that carbon. So let's make our 5-membered ring. Okay. For this carbon right here, one of these bonds is going to break as these electrons sort of swoop in, and you're going to get these 2 carbons are going to attach here. Something like that. Same thing for the others. Okay, so 2A, you're going to get a product that looks like that. Remember, you can always go backwards. Think about our exercise from a moment ago. If you started with this, you could say, well, how could I go backwards? You go back to this site right here. One of those bonds was new. We don't know which one, but in this case, this bond was new. So we could erase this. We could draw back in that double bond. This becomes our haloalkane, right? That allows us to go backwards and check our work. So that looks good. Let's compare that to 2B down below. In 2B down below, here's our Grignard reagent. So when this adds, these are the sites that are going to become partially negative. This is the site that's going to become partially positive. And electrons are going to flow from here to here, right? So think about where your alcohol group is going to end up. So this carbon is where the electrons were from. They're flowing over to this one. Oopsies. Let's park this right here for a minute. Now you can see as electrons flow in from your Grignard reagent, this is the new bond that gets formed, which means the alcohol group is actually going to end up over here. You see how that's a little bit different? Okay, 2 examples, similar, but not exactly the same.